And I'm going to show captions and I'm going to save it. Yes. Okay. Let me see if I have it still open in the downloads. I should. Let me check this out. Downloads 3.253. All right, here it is. Oh, that's the, I didn't get the homework? Huh. I should have gotten the homework too. Let me see if I did. Ah, there it is. There it is. Number
I already
2.
did number 1. Yeah.
Compute the probability of X successes using the binomial formula. Okay. So this time we want to put it in the binomial formula, right? Let me put this on the screen so we can see it. Zoom. All right, so we have, here we go. So we have N, we have P, we have X, right? And our formula for this is going to be, I'll put it above here. Let me write, there it is. So when you use the binomial formula, which we're only going to do when it's exact, okay, we're going to have the first part is, oh, actually, let me write, I guess, like that. P of X, and the binomial formula has a couple of different parts. So P of X is equal to N, choose X. So it's NCX times P to the power of X, and then Q, or 1 minus P, sometimes we call this Q, to the N minus X power. So what this is going to mean for part A, for example, N is 6, X is 3, and P is 0.03. So N is 6. Oops. Okay, hold on. Here it is. N is 6. X is 3. And P is 0.03. So if we're going to use the binomial formula, we're going to start with 6, choose 3. So, and choose X. So 6, choose 3. Then we're going to multiply that by P, which is 0.03 to the power of X. So we have 0.03 to the third power. And then the second piece of this is 1 minus P, which is 1 minus 0.03, which is 0.97, but I'll write it this way. 1
Yeah, I
minus
got that.
0.0, you got all that. Okay, that's good.
Yep.
So that all matches. And then N minus X is also 3 here. All right, let's see what we end up with when we poke this in the calculator. So let me do, hold on. Screen share. Let me open up the calculator because I haven't done it today. Give me a minute here. Let's see. We'll just move this out of the way. There we go. All right, it's opening. Give it a minute to open there. Share the screen and see what happens. So we get, let's see. I don't think it's showing up yet. No, it's not. Let me do something here. Where's my, okay, hold on. New share, there it is. Okay. All right, let's clear this out. Clear out all this math. I can click, clear from there, okay. All right, so we have 6 math probability NCR 3 times 0.03 raised to the third. And this is, whoops. This is, we're going to go down. We're going to say 1 minus 0.03, raise it to the third power.
Or 0.97 to the third power.
Okay, now, okay, so now here, yeah, you can also use, if you used, let's go back up. So if you used, oops. Let me grab the entry again, second entry. If you could have also gone ahead and subtracted. So if you did that, then you would have 0.97 here. And that should give you the same answer as
did.
what I have on the screen. And so remember here that when you have an exponent out here and it's negative, that you have to adjust this. So this means that your decimal is 4 places to the left of where it is right now. So that means that this is going to be 0 point, and then you'd move this over 4 places. So you'd have 3 zeros and then a 4 9. So that would be 5. 0.0005 would be your
Yeah, because
answer
I was
there.
looking at the answer key and it got 0.420.
Okay, let me see if, let me check. It could be a mistake. I haven't done these, so let me did you get all of them wrong or just this first one?
The first one I didn't do, but I did B and C.
So B and C didn't work either.
I would just like to check them.
0.346. I don't blame you. I would too. All right, let me check that. See what happens. All right, so number 2 says n is equal to 4 when x is 2 and p is 0.18. So n is 4, x is 2, and p is 0.18. So let's go back to here. Let me write it down. N is 4, x is 2, and p is 0.18. So here, okay, let's go back to the calculator and see what we've got here. So this is going to be, am I sharing the screen? No, I'm not. Let me fix that. Okay. Can you see? Probably not. I don't know what I'm sharing, but I don't think it's the calculator. All right, so now let me clear this out and we'll do it. So we have, this is going to be for letter B rather. N choose X, so it's going to be 4. Choose 2, math, probability. NCR 2, 4 choose 2 times P is 0.18. We're raising it to the X power, which is 2. And then we're doing the complement of P, which is 1 minus 0.18. That should be 0.82. Is that what you got?
Mm-hmm.
0.82, and we're raising that to the second power because 4 minus 2 is 2. So we get, this comes out to be 0.1307. Yeah, okay, so let's see. I don't think that matches her answer either, does it?
Nope, none of them answer.
They
And
don't match.
another
Okay,
thing,
I'll have, yeah, no, you're doing, let me check the third one and then I'll message her and ask, because I think maybe it's taken from, yeah, I don't know. I can't answer that. So the third one is, let's take a look at the third one. The third one's, or part C for that, says N is 5. N is 5, X is 3. And P is 0.63. Okay. All right, so we're gonna do this. We're gonna say, let's see if it works. Are you matching the answers that I'm getting though?
yeah,
Okay, good. As long as we're I'll let her know because I don't know what's going on with that. 5 math probability. NCR. Okay. Number, see, 5 choose 3. Okay. Probability is going to be 0.63. So we have 63. We're raising it to the third power. So 3 here. Then the complement of 63 is going to be 0.27. And then 5 minus 3 is 2. So this is going to be second power. We agree?
yeah.
I have 0.1823 for that. So this is 0.1823. And this was 0.1307.
I can't see the calculator.
Oh, I'm sorry. Did
It's
I
okay.
stop screen sharing? Maybe so. Let's see here. Let me figure out where I'm at. How about now, Jason?
There you go.
Okay.
Yep.
Yeah, I think those, I'll let her know right now so she can work on it. Did you find anything else?
Hold on. 5 choose 3.
0.63 to the third and 0.27 to the second.
I got 0.37. 1 minus 0.63 is 0.37.
Oh, did I? Oops.
Yeah.
That could be my, yep, it sure is. That's why we're human, right? All right, so let me change this. This, yeah, point. So I get, this is 0.3423.
Yeah.
Is that, and does that, but how about the second one? How about part B? Were you okay with part
Yeah,
B, which was
B was the
point?
same. C was the same. It was just A.
Point. Okay, so part A is the one that's off.
Mm-hmm. Yeah.
Okay. Yeah, quite considerably, I think. All right. Anything else for now?
Mostly all of 5.3.
All right, but I mean, you didn't find any other mistakes yet. All right, so let's see if we can do this. Are you having a problem finding the sentiment or using the binomial? What's going on with this
Oh,
here?
I was using the binomial.
Okay, so let's look at number 3. It says for exercises 3 through 7, assume that all variables are binomial. Okay, so if you're going to do at least 1 or 2 or 3, then we're looking at the difference between binomial CDF, cumulative probability, right?
Mm-hmm.
So number 3 says a television commercial claims that 1 out of 5 of today's marriages began as an online relationship. Okay. Assuming that this is true, calculate the following for 8 randomly selected today's marriages. Okay. So what we have to do here is we have to extract what the probability is. 1 out of 5 is our P here. Okay. So what does that mean our P is?
Hold on, let me go to the thing. P for 3 is 1 out of 5.
1 out of 5. And what is that as a decimal? We need a decimal for that.
0.20.
So for number 3, for all the parts, P is going to be 0.20. Okay. And your N is going to be how many?
Or 0.2. Does 0.2 also count as 0.20?
Yes.
Okay.
0.2 or 0.20. What is our N here?
Don't know. 8?
How many people are you selecting from? 8, right?
Mm-hmm.
So here we've got P is 0.2 and N is 8, right? Now what changes from one part of the question to the next is what X is, okay?
Mm-hmm.
So here 3A says the probability that at least 1 began online. Now, when you're doing these probabilities, okay, and you need to add up more than one probability, we do here, right? Then we can say this. This is where my binomial comes in, all right? So we're going to, let's do this thing. What do I want to do? Let me do this first and let me share screen. So for number 3, let me go here. For number 3, we have 3A, right?
Mm-hmm.
We know that N is 8 people. We know that P is 0.2 or 0.20, right?
Mm-hmm.
And my X is what changes. So here it says A is X is at least, so this is at least 1. Remember? At least 1. So when you have something that involves adding up probabilities, and here we do, she has a chart in here. Let me show you that. She has a chart for all of the different scenarios and what you put in the calculator. So let me show you this with the PowerPoint. Okay. Okay, this is about what constitutes a binomial. Here's your functions. Here's your answer. Here's how to put it in. Okay. Now, this gives you some help with, now, if you want to do the exact answer, you can also do the exact answer on the calculator as well. And you do that with PDF, P as in Paul. The other ones you do with CDF as in cat, all right? But she gives you the sections, and there's example 6 has pretty much an example of everything you'd ever want to do in here. But these are the ones that you want to follow. If you go back to slide number 15, equals is going to be PDF. Something with less than or equal to is going to be NP, and then whatever that number is. And if it happens to be greater, you start from the other end. So in this case, we're going to go for, whoops, it says probability that at least one began online. So here our X is going to go basically from 1 to 7, and it includes 1. So what that means is that we're going to go X here goes from 1 to 8. It doesn't include 0, but it includes all of these. So what we're going to do is we're going to say probability of X greater than or equal to 1, okay? And if you remember from slide 15, okay, when you're starting from other than 0, we have to use the 1 minus. So we're going to write equals 1 minus binom C as in cat, DF, binom CDF, N is 8, P is 0.20, and you you end it at 1 before this. So this is really just 0 in this case because it's greater than 1. So this is like doing 1 minus the probability of 0, okay? And that's what you put in. So you get, let's go in and do it. We have share screen. Where am I? Here I am. I'm gonna move this out of the way. So we're gonna go to the calculator. We're gonna put in, clear this out. Okay. Second clip. Clear. Okay. So we have 1 minus the where you find binom CDF is on the distribution menu. So you're going to go second, distribution, which is on top of the vars key. And then you're going to go down in the menu until you see binom CDF. This one for me is letter B as in boy. Binom CDF right here, hit enter.
Hold on, where do I go?
Okay, so it's second. Okay, so let me come back out. So it's, you have 1 minus on your calculator, right? Then go to second here.
Mm-hmm.
And then on top of vars, VARS is distribution, DISTR.
Mm-hmm.
Hit that. And then go down on the menu until you see binom CDF. For me, it's letter B,
Okay.
binomial CDF. And you're going to put in the number of trials, which is 8, because we have 8 people or 8 marriages. Our P is 0.2, right? And our X value, because we're going from 1 to something, we're going to stop. We're going to go 1 minus the probability of 0. So we're going to paste that in. And so we're going to end up with this statement here. 1 minus binomial CDF 8.2 and 0. Okay. And I'm getting 0.8322 when I do that.
Okay.
0.8322. Okay. If you're using binomial CDF, the reason we're doing 1 minus here is we're starting from other than that number. If we were counting from 0 up to something, we could just use binomial CDF. Because binomial CDF only knows how to count from 0, but we don't want to do that.
That's the first answer?
It should be the
Yep,
first
it
answer.
is. This one's
Okay.
actually right. Number 3 is actually right.
Okay. All right. So that's 0.8322. Now let's look at the next situation. The next situation says we're still with our 8 marriages, but it says the probability that 2 or 3 began online. 2 or 3 began online. So in this case, you have a couple of options. Okay. We want to add the probability of 2 plus the probability of 3. Okay. So we have a couple of ways we can do it. Probably the easiest way to do this. Either way, we're going to have to combine 2 things together. So it doesn't make a whole lot of difference. What we're doing here is we want to add 2 and 3. So for part B, we have the probability of 2 plus the probability of 3. Now, what we would want to do there is we will think about it like this. We want X to equal 2 or 3, right? So one of the ways we can do this is to do what we did before. We're not starting from 0. So here's what I can say. I can say that I can do binomial CDF. N is 8, P is 0.2. Now, I can go to 3. I can accumulate all the way up to 3 if I want, right? But here, I don't. Now, if I just stop here and do this one, 8.2 and 3, it's going to give me 0 and 1 and 2 and 3. I don't want that. So I'm going to subtract binomial CDF. I want to subtract 0 and 1. So I'm going to have 8 and 0.2. That doesn't change. Okay. But what changes is what I want to subtract off. Well, I want to subtract off all the way up to 1. So I'm going to put 1 here. Okay. That's one way to get your answer. Okay. You can also use the PDF, P as in Paul, and add the 2 together. But either way, you're going to get 2 terms. So here we have this is going to be, let me share the screen because I managed not to do that again. Let me go back to this. So I have second distribution, our favorite binomial CDF, 8.2. Now this time I want to go to 3 because I want to get 3 first. I want to add up the first 3, paste it, don't hit enter yet. Okay, that's going to be your first term. Then you're going to subtract the accumulated probability. So second distribution, binomial CDF again, 8.2. This time we want to subtract 0 and 1 because we only want 2 and 3. So we're going to go all the way up to 1 here. I'm going to subtract 0 and 1. We're going to paste it. And that should give you 0.4404 is what I have. 0.4404.
She does it round up or no?
What does she have on the
0.441.
441? Good question. She may have done them separately. I'll have her check it. Why don't you try part C and I'll stay on the, let me do something here. I'm gonna pause the video first. I don't know. Let me have her check it before we get too far into it. But I think that's what's going on there. So let me pause this. When you're dealing with CDF, a quirk of the CDF is that it only knows how to start counting from 0. Okay, so what's happening with part B for that is our outcomes go from 0 to 8. So our outcomes are going, they go from 0. Let's see if I can count today. They go from 0 to 8. Now, we only want these two from here to here, okay? That's all we want. So when you use binomial CDF, it's a convention in the way the program is written. It's nothing wrong with the calculator. It's just the way the program's written. The program is programmed to start counting from 0 all the time. So what we have to do if we use the CDF is we have to sort of make the problem fit. We want to get these two. We want to accumulate those two. So what we want to do, so what I do is this. I told it, all right, the first time you count, I want you to count.
It's one
So
time.
when I want you to count from 0 to 3. That was this. Binomial CDF. N was 8, P was 0.2, and I want you to count all the way to 3. So it did that. It accumulated 0 plus 1 plus 2 plus 3 and gave me that. But I don't want all of those. I just want 2 and 3. So what I'm going to do is I'm going to tell it, all right, now from the answer that you just gave me, I want you to subtract the ones that I don't want. And the ones that I don't want are 0 and 1. So what I'm going to do is I'm going to say, okay, well, this is 8. This is 0.2. And I want you to subtract up to 1 from it. Because I don't want those. I just want 2 and 3. So that's essentially what the calculator did, was we went up to 3 and then we took off what we didn't want.
But it didn't count 2.
It did count 2. It did count 2 because the first term here, so this first term here counted these. It counted the probability of 0, plus the probability of 1, plus the probability of 2, plus the probability of 3. So it counted that. That was the first piece. This was binomial of this thing here. Then what we did was we subtracted from up to 1. So we subtracted this. We subtracted the probability of, let me write it in brackets. We subtracted the probability of 0 and the probability of 1. So when we did that, see, the 0 and the 1 went out, and what were we left with? We were left with these, which is what I wanted. It's a little trick you have to use when you're dealing with binomial CDF and you're doing something other than starting from 0. If I wanted like the probability of everything less than 6, say, for example, or less than 5 or less than equal to 4, I could start from there. But if I'm starting in the middle, then I have to do this thing of going all the way up to the top of what I want and then taking off what I don't want.
Okay.
Good question. Good question. But that's why.
And I
we did
ended
that.
up with 0.440, not 0.4, not 0.441. So I think
That's
that
fine.
one's wrong.
4404 is correct. That's correct. Like I said, she's gonna have to go back and fix it. So give her a little time too, because she's got to fix those and figure out what happened with the section, because she found some other ones when she started looking at it. So she's gonna, let me go here. So are we ready for number 4 now?
Yes.
Okay, cool. All right, let's look at number 4. Okay. It is reported that 77% of workers age 16 and over drive to work alone. Choose 8 workers at random and find the probability that. Okay. So always identify your P and your N. Okay. So what is my P here?
P is 77%.
Right. P is 0.77. How many N do I have?
N 16.
No, that's how
Oh,
old they
8.
are. 8 workers. Right. Yeah, don't confuse how old they are with how many there are.
So N equals 8.
Right. N is the sample size, the number that we're selecting from. Good. So for number 4, P is 0.77, N is 8. Part A says all. How many is all?
16.
No. That's how old they are. How many workers is it?
8.
All 8, all the workers drive alone, right? So what this question is saying is 77% of workers drive to work alone. Choose 8 workers and find the probability that all 8 drive to work alone. So here, number 4A is going to look like this. You have, let's do 4A. So this is going to be 4A. We know that P is 0.77, N is 8, and I want to find the probability that 8, now here my X is 8, just 8, right? Probability that all 8 drive to work alone. So here, what am I going to use, a PDF or a CDF for this?
PDF?
It's a PDF, so remember that, binom PDF, okay? And we're going to put 0.77. I'm sorry, we're going to put 8 first. Then we're going to put 0.77. And then we're going to put 8 at the end because this is my X. So the first one is my N. How many am I choosing from? Then my
8.
percentage, then my 8 here. Okay, so let's do it and see what we get. So we get, let me make sure I'm showing the calculator. I have a
1, 2.
bad habit of not doing that today. So we have second distribution, binomial PDF, which is A on your calculator, 8, and it change your 0.2. This is 0.77. And we're doing 8, and we get, I'm getting, what am I getting? 0.1236 if I round, 0.12357. 0.1236 is what I have.
I got that too.
Okay.
And it
cool.
rounds up to 0.124.
0.124. Good job. All right, let's go back to the homework and let's look at this now. The next one says more than 1/2 drive to work alone. More than 1/2. Okay, so how many workers is that?
More than 1/2. 1/2 is 0.5.
Okay. Half of how many though?
8.
Yeah. What is half of 8?
8 divided by 2
Okay.
is 4.
4. So this is another way of saying more than 4, right? So here you would do, if you were going to do this calculation, you would take half of 8, which is 4. So we want to find the probability that more than 4 drive to work alone. So in this case, we have to do a little thinking here, not too much, but a little bit. So we're looking at more than 4 drive to work alone. So in this case, we have 4B, right? We still have P is 0.77. N is still 8. Okay, but now here, this is X is more than half. So, and I'll just put of 8 in brackets because that's our group. And if you wanted to show this so that you remember when you're studying it, half of 8, as you said, this is 0.5 times 8. And you work that out. That's 8 divided by 2. This is 4.
4.
So really, this is saying that X is going to be more than 4. So X is, now, it's more than 4. So you don't want to include 4, more than half. 5, 6, 7, or 8 is what we want, right? What we would write is we would say, if you wrote this out, you would write this. You would say the probability of, since X is more than 4, you would write X is more than 4, okay, like greater than 4. And you would write this as, now, if we're starting somewhere other than 0, as we are, then we need 2 expressions. So this is going to be binomial PDF. Oops. We have 8.77, and we want to go to our maximum, which is 8. So we want to add up all 8 of them. But then we have to subtract the ones we don't want, okay? And the ones we don't want are the first 4. So binomial CDF, this is going to be 8.77, and we want to stop subtracting when we get to 4. So we want to add up 5, 6, 7, and 8, which is what this command will do for us. Okay, that's this. Questions about that?
Nope.
No?
I think I get your point.
All right, let's put it in.
So more than half is subtraction?
Well, no, it's only subtraction because the calculator needs us to do that. More than half means we're adding 4 people, 5 people, 6 people, 7 people, or 8 people. It doesn't include 4 because 4 is exactly half.
Mm-hmm.
Okay, so binomial. So we're going to have, let's go share our screen and see what we get. See if we got the answer here. New share. So we get second distribution, binomial CDF. This is going to be 8.77 and 8. Paste it, don't hit enter yet. Minus second distribution, binomial CDF, 8.77. We're going to subtract 4 from it. Paste it. I get 0.9120. What I have.
I got that too. That's correct.
Yay. Okay. Next question for part C. I think it's an exact one, if I remember. What is the probability that exactly 3 drive to work alone? Exactly 3.
So I
So
think
if
it's
it,
binomial PDF.
that's right, exactly 3. Very good. So in this case, it's second distribution, binomial PDF here, 8.77, and it's exactly 3, so we don't have to worry. We just put 3 in there,
Mm-hmm.
paste it, hit enter. 0.0165 if I round, because it's 645. So
That's
it's
correct.
0.165. Okay. Questions about this?
No.
No? Okay. Let's go to the next one now. Next question, number 5. In a survey, 3 out of 4 students said that courts showed too much concern for criminals. Find the probability that at most 3 out of 7 randomly selected students will agree with this statement. Okay. So let's start. How do we start this?
Survey. I don't know.
What do we need to be able to find probability?
The probability. Oh, wait, no.
We need to know what P is. You're right. We need to know what P is. How do they tell us what P is here?
Yeah.
What is it?
3 out of 7.
Be careful. Be
Or 3 out
careful.
of 4.
This is, yeah, we want to find this probability. Find the probability that at most 3 out of 7 will agree, right? That's the one we want to find. But the one that, let me ask it this way. How likely are the students to agree with the statement?
3 out of 7.
No.
3 out
Okay.
of 4.
3 out of 4. In a survey, 3 out of 4 students said that the court showed too much concern, right? So this 3 out of 4 is your P, but it's disguised, right? How do I turn that into a probability?
You divide 3 out of 4,
Yeah, I divide it.
which equals 0.75.
There you go. That's your P, because that's how likely they are to agree. So on number 5 here, we have 3 out of 4, which is 0.75, right? And what's happening is this. This is my P right here. That's P. Now, I interviewed 7 people. That's where my 7 comes from. N is 7. Now, what they're asking you is, we want, and I'm going to do this again so we can show, so I can show you, because this is the hardest part, I think.
Wait, N equals 7?
Yes.
How
There were
come?
7 people, weren't there?
Oh, yeah, this says 3 out of 7.
Yeah, we're gonna get to that, but we interviewed 7 people, right? N is the total number of people that we selected, not how many agree with us.
Oh.
N is the total. X is how many people fit the characteristic. Okay, so in this case, that might be where it's getting a little bit confusing also. Right here, we interviewed 7 randomly selected students, right? We want the probability that at most 3 agree with our statement. So at most 3 people. Could be 2 people, could be 1 person, could be nobody, but we don't want more than 3 to agree with us. Okay. So in this case, we're going to write this. We're going to say, before we calculate it, we're going to write this. We're going to say that X is going to be at most 3. So here, if you want to see the numbers, because sometimes it helps people. This is 0, 1, 2, or 3 in this case, out of this number here. So what we would write is the probability of at most 3 would equal the probability of 3 is the most. So we have less than or equal to 3. 3 is the most, and we go down. Remember, we're starting from 0 here, so that's a good sign. We're going to use binomial. There's no 1 minus in this case because we're starting from 0. So this is binomial CDF. We have 7 people. Our probability of agreement is 0.75. And we're looking at most 3 people. So we're looking at that. 7.75 and 3. Make sure you're using the CDF function. So now, questions here. And a question about this?
No.
No? Okay. So we do. This is going to be second distribution. Binomial CDF. 7.75 and 3 people. Paste it in. 0.0706 if I round it. Okay. So this is 0.0706. Because it's 5
And it
times.
rounds up to 0.071.
Mm-hmm. Yeah. Good. Okay, let's do the next one. Now we have, let's see. Okay, so 6 has multiple parts. But let's find our N and our P so we can figure this out. So R.H. Bruskin Associates Market Fund Market Research Fund found that 40% of Americans do not think that having a college education is important to succeed in the business world. If a random sample of 5 Americans is selected, find these probabilities. Okay, what is my P for number 6?
40%, which is 0.4.
Good. P is 0.4. What is my N?
N equals 5.
5 people. All right. Now, looking at part A, exactly 2 people. What is my X?
2.
Yeah.
And
And
it's
am I going to use PDF or
binomial
CDF here?
PDF?
Yes. Very good.
Mhm.
Very good. So now we just do that. So number 6 is going to be this. We're going to say second distribution, binomial PDF, and we're going to put in what you said. N goes first. N is the number of trials. That's 5. P is 0.4 or 0.40. And my X here is 2. Paste it. And I get 0.3456.
Mhm.
Okay, let's continue. Let's go back to number 6 and see what it says for B. B says at most 3 people, will agree. Probability of at most 3 people. Okay.
Mhm.
So what are we gonna do here with part B?
Subtract.
Okay, are we starting from 0 there?
No.
Are you
No.
sure? At
Oh,
most
yeah.
3, yeah, at most 3 means 3 or fewer. Right? 3 is the most. So on B, we don't have to subtract. We just use, for number 3, all we're gonna do, we're gonna use the CDF because we're accumulating, but we're gonna use second distribution. This is going to be binomial CDF. We have 5 people. We have a 40% chance they're going to agree with us. And we want at most 3 people. So we want to accumulate up to 3 people. Okay.
Mm-hmm.
3 people. And we're going to paste it in. 0.91296. So it's 0.91. Actually, that would, if you rounded to 4, that would be 0.9130, right? If I rounded
On
it.
the key on the answer key, it says 0912.
1, 2,
Oh,
okay.
wait, hold on. Wait, hold on. No, you're right. You're right. I was looking at the wrong one.
Okay. All right, so that's that one. Now let's go to the next one here. Now,
At least.
now when you start, this is 2 or more people. 2 or more people, okay? At least 2, so 2 or more people, right? When you
Mm-hmm.
start from something other than 0, that's when you have to subtract it. So here we're subtracting something. At least 2 people will agree. So here we're going to do this. We're going to say, first we go all the way up to where we want to be, which is 2 people, right? I'm sorry, at least 2 people. So we want to go all the way up to 8 people, right? So second distribute, I mean, not 8 people, 5 people. This one has 5 people. Second distribution, binomial CDF. You want to be, you have 5 trials. That's right. You have 0.4. This time you want to go all the way up to 5 people first. So paste that, then subtract. You want at least 2 people. So now here's the thing. When I subtract it, I want to include the 2, right?
Mm-hmm.
So when I subtract it, I'm going to go second distribution. I only subtract the ones I want to get rid of, which is 0 and 1. So I'm going to stop my X value here, not at 2, because I want to include that. I'm going to stop it at 1 here, because I want it to subtract 0 and 1 for me. Okay. So let me let you look at the command line again. So this is binomial CDF 5.4 and 5, because I want to go all the way to the top. And I want to subtract the first 0 and 1. I don't want to subtract 2 because I want 2 or more people, right? So at least 2 people is 0.66304. Probability of X greater than or equal to 2 is 0.6630. Okay.
Yeah, I got that.
All right, cool. Next question says, we have one more. Okay. Okay, now this, don't let it trip you up. This is fewer than 3 people. Fewer than 3 people. So here we want 0, 1, or 2 people. Okay. Fewer than 3. Be careful there. It doesn't include 3 this time. If it was at most 3 people like B, we would include that. Fewer than 3 means we have to stop before we get there. Okay, so we're going to have, for fewer than 3 people, probability of X less than 3 people. This is going to be, I'll write it here first. This is going to be the probability for D. This is the probability of X less than 3 people. That's going to equal binomial CDF. And since we're starting from 0, I don't have to worry. 5.4 and less than 3. So I want to stop at 2 here. I have to take 1 off of where I stop. I don't have to subtract the binomial, but I have to take 1 off the end of it.
So minus.
Okay. So 5.4 and just 2. We're not subtracting any other function. We're just taking 1 off of where we would stop. Instead of this being a 3, it's a 2 now. You see that?
Yep.
So here we go with, this is second distribution. This is second distribution. Binomial CDF. 5.4 and 2. Fewer than 3 people. And we paste it in. 0.6826 is what this is.
Wait, hold on. Binomial CDF.
0.6826.
Hold on. Oops. Okay, I got it now.
Okay. I think we have time for one more. Let's try that. Let's do number. Okay, let's share a screen here. Is there more parts to this, or is there a number? Oh no, now we're on number 7. Okay. Yeah, we'll do number 7 and then we'll stop there. 53% of all persons in the US population have at least some college education. Choose 10 persons at random and find the probabilities. Okay. All right. What do you think, Jason? What should we do?
Find the probability.
Okay. What probability did they give us? What is my P here?
53%.
Yeah, that's right. 0.53. And what is my N here?
N equals 10.
Very good. N is 10. Now for part A, what is my X?
Exactly 1/2, so 0.5.
0.5 of my X should be a whole number. So you're right with the 0.5, but what am I taking half of?
53?
No.
No.
How many people is it?
Oh, 10.
Yes. When you're doing the probabilities down below, okay, it's some portion of whatever N was. Okay, it's not changing this P. It is a portion of however you're choosing from. Exactly 1/2 of the people that you choose, well, you chose 10 people, half of 10 is 5, right? Now that's exactly 5. So what are we going to do to find that?
Times it by 10.
Okay, so 0.5 times 10. Let me show you this. That's the right answer, but that's not the question that I'm asking you. Let me go back. So this is you have 10 people, and this is you have 53% of people have a college, some college, right? And you want probability that exactly half, exactly 1/2. Okay, so then you said, well, this is 0.5 times 10, and that's correct. 0.5 times 10 is what? It's 5 people, right?
Yep.
So this means that when you write this, this is probability that X is equal to 5, right? Now, how am I going to find that? What am I going to put in the calculator for that?
Binomial PDF.
Right, binomial PDF. Binomial PDF, and we're going to put what?
Binomial PDF. You'll put in 10.53.
Yes, 10. Then, okay,
and 5.
5. Very good. That's right. That's what you're going to put in. So let's do that. You're probably ahead of me already. Second distribution. You have binomial PDF.
Mm-hmm.
We've got 10. Got 0.53. And we've got 5. Let me put it on the screen. I have it on the calculator, but I don't have it on the screen. Let me put it on the screen here. So here's my, and I get 0.2417 is where I would round.
Mm-hmm.
Okay. Let's take a look at part B of the question.
Mm-hmm.
Part B of the question for number 7 says
At least 5.
at least 5. So 5 is the smallest. 5 is the least. This goes from 5, 6, 7, 8, 9, 10. What are we going to do there?
Subtract.
Yes, we are. Very good. So here we get, this is going to look like this. So we're going to say, when we write this out, it's going to look like probability of at least 5 is going to equal probability of X greater than or equal to, because this time it includes 5, right? Greater than or equal to 5, and that's going to be, now, greater than or equal, go all the way up first. So then you have binom CDF, sorry, binom CDF. This is 0.53. And we have, I'm sorry, I forgot my N. N is 10. 10.53. And I have to go all the way up to my maximum, which is 10 people. Right? Now I'm going to subtract, as you said, binom CDF. It's going to be 10.53. And we're going at least 5. So we want 5 to count, which means we stop at 4 here. Okay. That's because that includes 5. So you want to stop at 4. The ones you want to take off, stop at 4. So this is going to give us our statement. This is what you would write on your paper, and then you can just write your answer there. Okay, so let's do this. This is second distribution. Binomial CDF, the bad habit of that today. This is 10.53 and 10, because we started with 10 people. Then we're going to subtract second distribution. Second distribution. We're going to go binomial CDF. 10.53 and 4. I'm going to paste it.
I can't see the calculator.
I'm sorry. It says
It's
I'm
right.
sharing. Maybe I wasn't sharing. No, I was sharing the homework screen. Sorry. There we go. So let me bring it up. Here's your expression. Binomial CDF. Let me come back. Binomial CDF 10.53 and 10. So always go to the maximum. Then subtract what you don't want. Binomial CDF 10.53. I want 5. I want 5, 6, 7, 8, 9, 10. I don't want the first 4. So stop at 4. And I end up with 0.6943.
I got a different answer. Oh wait, the answer key is different.
Is it?
Yeah, it's
What is
0.547.
0.5. Okay. I'll did I read the problem wrong? I don't think so, but let me check. Let me check and see. At least 5. Do not have any. I'll flag it. That's 7C, right?
Yep,
Okay.
or 7B.
7B. All right. You haven't tried C yet. Okay. Fewer than 5. Fewer than 5. In this case, we're accumulating, but we're not accumulating 5, and we're starting from 0. So fewer than 5 is going to be fewer than 5. We have fewer than 5 is going to be probability fewer than 5 is going to equal probability X this case, less than 5. Fewer than 5. So we're going to go with equals. This is going to be binomial CDF 10 0.53 and we're doing fewer than 5. So we don't want to include 5. So we're going to go to 4. Okay. So this is just basically the second half of the last expression that you entered. And let's see what that gives us. So we get, oops, new share. Okay, can you see the calculator?
Yes.
All right, so second distribution. We have binomial CDF. Oh, this is going to be that one. 10.53. And we're doing 4. We're just doing this part. And I have 0.3057. 3057. Okay.
It's also still not.
That's not correct
It's
either. Yeah, I'll go ahead and see how you do. The other ones have to do with finding the mean, the variance, and the standard deviation, which is a different formula. The formula is in the slides, okay? But those have to do with that one. So I'll let her know. I'm sure that'll be up by probably the end of the day today, but yeah, I don't know why that's as off as it is. But you're getting the right answers, Jason. So I think
okay.
we're good. Okay.
Yep.
I'll see you again tomorrow.
Sure.
All right. Take care.
Mm-hmm.
Bye now.
Goodbye.